Very good evening to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? I think we are live. Yeah. First of all, do comment करके बोलिए. Is the audio videos clear to everybody? Yes. I'll have to do like the session and share to all your friends. Yeah. So you can find the top educators team. You can find एक साथ आपको मिलेगा इधर. Have a look at now here. Top educators team आपको मिलेगा. So we starting from 28th April onwards. We started the new batches. We have started. So you can find the top educators team here. And you can see now EDC and aptitude is going to start. So these are the GATE 2026 ka rankers you can find. These are from Unacademy and ESG 2025 ka rankers. You can find these things. Unacademy starter kit is available and Unacademy Una. There are 3 modes are there. You can see now voice mode, quiz mode, smart summaries. So if we ask to prepare a quiz on so and so topic, it will automatically create the quiz for you. And test series is available. And we do offer the 2 subscriptions. You can have a look at now here. The one is a plus subscription, other one is iconic. Plus में आपको top educators classes मिलेगा, live doubt solving, evaluated test series, structured courses, PDF, live test, unlimited access. एंड आइकॉनिक में आपको क्या मिलेगा? आइकॉनिक में आपको क्या मिलेगा? सो ये पर्सनल कोच भी मिलेगा एंड फिजिकल नोट्स भी आपको मिलेगा, राइट? And you can book your slot according to your time convenience and connect with your mentor. And these are the GATE 2025 rankers from Unacademy. Now, see this thing here. We have discussed some problems we have discussed yesterday, and we'll continue the remaining problems now. Last 20 problems we have finished now. Right, take the next problem. For the circuit shown, the value of current at t is equal to 3.2 seconds is. For the given circuit, the value of current at t is equal to 3.2 seconds is. Now, so here basically this current I, which will be given as what? Tell me now. Yes, I, which is equal to V, that is V of t minus 5 by 1. And we need V of t. So V of t, we need the current at 3.2 seconds. So 3.2 seconds at these locations. We need the voltage required now. So here this is a straight line, and but it is not passing through origin. So then this equation of this line, which is of the form y equal to mx plus c. This equation is what? Tell me now. Y equal to mx plus c form में होगा. And tell me now here we can say now V of t. Y means V of t M is the slope now here. Slope of this line. How much you tell me now? So 5 by 1. So that is what we can say now, 5t plus C is a constant. So constant we need to get. So to get this constant, we can take any point on this line. See the coordinates of this point is now here 4, 10. And substitute this point on this equation. Now when t is equal to 4, so v of t, how much the v of t, which is equal to 10. So put this one here. 10 is equal to what we can say now here, 5 into 4 plus c. So how much the c value, tell me now here, 10 minus 20. And which is equal to c is equal to minus 10. So then what I will get now here, we got the v of t. V of t, which is equal to, this is 5t minus 10. 5t minus 10. So now we need the voltage at t is equal to 3.2 seconds. Put the t value 2.2 in the above equation. So we will get this value v of t when t is equal to 3.2. How much this value? This is 5 into 3.2 minus 10. How much we'll get now here? So this is 15, 10. So 16. 16 minus 10, which will be equal to what element of here? 6. So that is what I'll get you element of here? I, which is equal to 6 minus 5 by 1, which will be equal to 1 ampere. Next, two wires of same length and thickness having specific resistance 6 ohm centimeters, 3 ohm centimeters respectively are connected in parallel. The effective resistivity is rho ohm centimeters. The value of rho to the nearest integer is, the value of rho to the nearest integer is, right. So I have two resistors now here, that is R1, which I can say it as what I'll be now here, rho L by A. They are saying the same length and same thickness. Now this is R2, which is given as, that is rho to L by A. And these two are connected in parallel connection. So this means, what is the effective value of this thing here? That is rho effective. Length is same now. By area will becomes what tell me now, A plus A. So this will be same area. So that's why it will become, total area will become 2A. So since these are connected in parallel, equivalent resistance is what I can say, that is 1 by R equivalent. 1 by R equivalent equal to what tell me now, 1 by R1 plus 1 by R2. That is given as 2A by, that is rho equivalent into L, which is equal to, that is A, that is rho 1 into L plus A, that is rho 2 into L. So then simplify now, A will get cancelled, L also will get cancelled. So we'll come it as 2 by, that is rho equivalent, equal to what tell me, 1 by rho 1 plus 1 by rho 2. Now you tell me now here finally. So this is, if you take it as, what is this row equivalent now here? So we'll come it as, that is 2 row 1 row 2 by row 1 plus row 2. And simplify, substitute the values and simplify it now here. So this is 2 into what we'll get now here, 6 into 3 by, that is 6 plus 3. That is row equivalent is what element now here, 2 into 6 into 3 by, which is equal to 9. So this value 3 3s, 3 2. So which will be equal to what element of 4 ohm centimeters. Right. Next one. A current through a wire depends on time. I is equal to alpha t plus beta t square. Find the charge crossed through the section of the wire in 15 seconds. 15 seconds means we can take it as 0 to 15 seconds. So they given this current I, which is given as a 20t plus what element of 8 into t square. So we need to get the charge, we need to get charge is equal to integral of I into dt. And so that is given as integral of I. So 20t plus 8t square into dt. So this is 0 to 15. Yeah, simplify now. So what will come here? Q is equal to 20t squared by 2 plus 8t cube by 3. And the limits are 0 to 15. And substitute the limits and get it. So this is Q, which is equal to 10 into t square. 15 square minus 0 plus 8 by 3 into, that is 15 cube minus 0. So how much will come here? 15 square means 225. 2250 plus 15 cube. How much the 15 cube is a? Yes, so 3375 by 3 into 8. So this value 9000. So that means how much this value? So that is 11,250 coulombs. So second option. Next one. A wire of resistance 1 ohm and length 1 meter. 1 meter. It is stretched till its length increases by 25%. The percentage change in the resistance is, I stretch it now, so that means resistance proportional to L square. So that is, we can write as R2 by R1, which is equal to L2 by L1 whole square. So we have L1 here, which is 1 meter. Length is 1 meter. And this L2 is what tell me now? That is 1.25 meters. Now substitute them here. This is will come R2 by R1 and which is equal to 1.25 by 1 whole square. So we'll come it as what tell me now here? R2 by R1. Yes. And which is it? Okay, I will add 1. So this is minus 1 if I do here. So it is 125 by 100 whole square minus 1. Then R2 minus R1 by R1, which is equal to how much now? Cancellations. 25 fives, 25 fourths now. Then it will become 25 by 16 minus 1. So we'll come it as R2 minus R1 by, this is R1 into 100, which is equal to 25 minus 16 by 16 into 100. So which will come to be a 9. So 9 by, so 16 4 fourths. So here 4 25s. 4 into 25. So this value 25 into 9 divided by 4 will come 56. That means will come to be a, so that is R2 minus R1 by R1 into 100, which is equal to 56.25%. So that is 56. Yeah, good afternoon. Then, next one. The charge on a capacitor placed in a circuit as a function of time is shown in figure. The value of current is, okay, charge is given, they are asking to find the current. So I is equal to what I will have dq by dt. So here at t is equal to 4. So how much the charge you tell me now here? Q, which will be equal to 2 coulombs, fixed value, it is not variable. So that means I is equal to what tell me now? dq by dt. It is a constant now, constant ka derivative 0. So that means current is 0. The resistance of a wire is 5 ohms at 50 degrees and 6 ohms at 100 degrees. The resistance of the wire at 0 degrees is, the resistance of wire is 5 ohms. The variation of resistance R equal to what tell me now here? R naught into 1 plus alpha T. R equal to R naught into 1 plus alpha T. And which will be given as resistance is what tell me now here? 5 ohm. 5. So at what now here? At 50 degrees, R naught into 1 plus, that is 50 into T. And that is 6 is equal to R naught into 1 plus 100T. 100T. Yeah, you can simplify now here. That is 6 by 5, which will be equal to 1 plus 100T by 1 plus 50T. 1 plus 50T. So you can cross multiply, simplify here. So that is 6 plus, so here 30. So this is 300T, which is equal to 5 plus, that is 400T. Now we'll come it as 1 is equal to 200T. What here? What we're finding here? No, T given alpha is not there now. Alpha we should find now. Alpha, this is alpha. P value we have, that is 6 by 5, which is equal to 1 plus 100 alpha by 1 plus 50 alpha. So this is 6 plus, that is 300 alpha, which is equal to 5 plus 400 alpha. So that is 1 equal to 200 alpha. That means alpha equal to 1 by 200. Now we'll substitute this value. So that is 5 equal to that is R naught alpha R naught also R naught we need to find. So this R naught into 1 plus, so here 50, 50 by 200. So this value which is equal to 5 equal to R naught into 1 plus, this is 5 4, so that is 1 by 4. So this is 5 equal to R naught into, that is 5 by 4. So that means R naught equal to 4 ohms. 4 ohms. Yeah, good problem. Next. An electric current is passed through a circuit containing two wires of same material connected in parallel. If the length and radius are in the ratio of 4:3 and 2:3, then the ratio of the current passing through the wires is, how they are connected? Two wires parallel connected. Parallel connection, potentially same, voltage same na. So they asked him to find this current. So this is I is equal to V by R. So that means, and R equal to what? Tell me now. Rho L by A. Same material means rho value constant. So that means R proportional to L by A. So here from this I proportional to 1 by R. So from this what I can say now, I proportional to A by L. I proportional to A by L. Okay. A by L. So that I can say this as I proportional to what L, R square by L. I proportional to R square by L. So this is I1 by I2, which is equal to R1 by R2 whole square, L2 by L1, which is equal to, if the length and radius are in the ratio of length ratios is given as 4 by 3, L2 by L1 is what? 3 by 4, R1 by R2, so that is 2 by 3 whole square. So then it will come to be a I1 by I2, which is equal to, that is 3 by 4 into 4 by 9. 4 will get cancelled, 3, so it will be a 1 by 3. Option B. Next. Yeah, take this value as a, this is 10. Now you can tell me. Yeah, so I'm calling this point either something C, and this point is also C only. If I say this point is D and this point is also D only. So let's form a bridge now here. And so this is given as A, this is B, this is C, and this is D. Now, so we have the resistance between the elements, we'll place them. So here A to C, we have a resistance. A. Now A to D, we have a resistance. How much is value? 6 ohms. Right. Next C to D, we have a resistance. This diagram is not good. So here I have taken a point. Now here this point is A. And so this point is D. And this point is C. And this point is B. Right. So A to D, how much the resistance you tell me now? And that is 6 ohms. C to D, how much is resistance now here? 15. This is 15. Again C to D, this resistance which is again 15. Next, again C to D, this is also 15. And this is also 15. Next, C to B, this resistance, how much this value which is 8. Now tell me now here, how much this value is equivalent now here. These three are parallel, which will become as 5 ohms now. So from this we can say now RAB, which is equal to 6 plus 5 plus 8, which is equal to 19. Option D. Next one. In the given figure, an ammeter consists of a 240 ohm coil connected in parallel to 10 ohm shunt. The reading. Okay, in the given figure, an ammeter consists of a 240 connected in parallel to a 10 ohm shunt. Okay. How much the equivalent resistance of this ammeter? Tell me now. Equivalent resistance of this ammeter. So 10 and 240 connected in parallel. So yes, 240 into 10 by 250. So this value will get cancelled, 5 2s and 5 5s, which is equal to 48 by 5 now will come to be a 5 9s. So here 45 3 6. Okay, this value. Now this ammeter, this will have a resistance is whatever we know, that is 9.6 ohms. The total resistance, then the current I, which will be equal to 24 by, so 140.4 plus 9.6, which will come to be a what, tell me now here, 24 by, so 150. So then this value, I value, will come to be how much? 24 by 150. So this is 0.16 amperes. In milliamperes they are asking now. That means 160 milliamperes. 160 milliamperes. Next one. In the given figure, R1, R2, R3, R4 and battery is ideal with a 12 volts EMF. Equivalent resistance of the circuit and the current supplied by the battery are equivalent resistance. So here R1 resistance, this is 10. So this is 8. This is 4. No, this is 8. R3, this is 4 and this is 8. Okay. Now these two will be 4, 4, 4. It is 2. 2 and 10, 12. So R equivalent and which is 12 ohms. R equivalent is 12. Then what about the current you tell me now here? 1 ampere. Next, a wire of resistance 20 ohms is divided into 10 equal parts. A combination of two parts are connected in parallel so that and so on. Now the resulting pairs of parallel combination are connected in series. The equivalent resistance of final combination is a wire of resistance 10 or 20 ohms is divided into 10 equal parts. Then resistance of each part will become 2 ohms. Okay, a combination of two parts are connected parallel. So that means each resistance will become what I know 1. 1 and these are connected in series. Then it will become what element of here 1. So here like this 5. So that is final equivalent resistance will become what element of 5 ohms. Check it all of you. Correctly now. Next, equivalent resistance of the network is equivalent resistance. So here, okay, the short is there. We can say this is the dead element. Remove it now. And so then 2, 2 parallel 1. 1 and 2, 3. 3, 3, 1.5. 1.5 and 3. So this value is 1 and this value which is equal to 3, right? And so then finally this 3, all threes are in parallel. So what is the equivalent resistance now? RAB, which is equal to 1 ohm. Which one you asking? Yeah, this thing only now. This is 5 ohms. This one. Next, a potential divider circuit is shown in figure. The output voltage V0 is potential divider circuit. That means this voltage. How many? 1, 2, 3, 4, 5. So this value which is equal to, we can redraw this part of circuit as now this is will divide into two parts of circuit now like this. And this value which is equal to 4 volts and this is 400 ohms and this value 3.5, that is 3500. And they are asking to find this voltage, they are asking to find this is V0. So that is V0 which will be equal to what you tell me now here, 400 by, yes, now here 3400 plus 500 into 4 Now simplify it now. So this is V naught, which will be equal to 400 into 4 by 4000. 4000. So two zeros will get cancelled. This is 4 tenths, which will be equal to 0.5. Next, a 16 ohm resistance is bent to form a square loop. A 9 volts battery with internal resistance 1 ohm is connected across one of its sides. Okay. If a 4 microfarad capacitor is connected across one of its diagonals, the energy stored by the capacitor is. So a 16 ohm resistor is bent to form a square. Okay, so it is bent to form a square. A square is formed like this. Okay, so that means each part will have a resistance equally now, since all sides are equal, right? So this value, which is a 4 ohms, and this value 4, this value 4, and this value is also 4. A 9 volts battery with internal resistance 1 ohm is connected across one of its side. So let us consider here this 9 volts battery is connected with the resistance, internal resistance of this battery, which is 1. Okay, so this is 9 volts and this is 1 ohm. They connected like this. If 4 microfarad capacitor is connected across one of its diagonal, so here this diagonal they connected. Let us consider. Here the capacitor is connected in the diagonals, and that is what tell me now here, that is 4 microfarads. Then they are asking to find the energy stored by the capacitor. So of course we are applying a DC supply, so that's why capacitor will behave like what tell me now here, open circuit. Now, so let's find out the things now. VA and VB we need to find. Okay, so you tell me now here. And what are the equivalent resistance now here, first of all. So this thing. Now these three are in series. So 12 parallel to 4. And this is 4 parallel to 12 now, which will come to be a what now 12 by 4, which will be a 3 ohms. And this 3 and 1. So 3 ohms plus 1. So that means equivalent resistance, which will be equal to a okay, how much will come here? 3, and this is 3 plus 1, that is 4 ohms will come. Then how much is value of current now here? I, which will be equal to 9 by 4. So that means this current, which will be equal to 9 by 4 amperes. Now this some current will go here and some other current will go here. If I call this current is I1, this current is I2. Yeah, tell me now here, how much is I1 and I2s? We can apply the CDR. So tell me now here, this is I1, which will be equal to, in this branch current, so that is 4 by 12 into what we can say now here, 9 by 4. 4 by, so this value 4 by total, it is 12 plus 4, 16. 16 into 9 by 4. 4 will get cancelled, which will come to a 9 by 16. So this is I1. So what about this I2 value? Tell me now here. Oh no, this is I2 only. This is I2 value we got. That is 9 by 16. Now we need this voltage here. So this voltage we need now here. This voltage, if I say V, so tell me now here V value, which is equal to 9 by 16 into 4 plus 9 by 16 into 4. So how much will come this V value? So this is 9 by 16. So this value will come it as 8. So this is 2, which will come to be 3.5. That means the voltage across capacitor is 3.5. We need what tell me now energy stored by the capacitor, which I can say it as of CV square now, and which will be equal to 1 by 2 C value 4 micro, that is 4 into V square, so 3.5 whole square. 3.5 whole square. And so this is microjoules. So how much will come here? 2 into 3.5 whole square microjoules. So tell me now 2 into 3.5 whole square. This value, how much will come? Oh, they didn't cancel this thing. So that's why we need to keep this 1 by 2 as it is. Now we can say this as 3.5 square into 4. That is 49. 49 microjoules. So this is answer. Next, in the given circuit, the current in the resistor R3 is. Here the R3 is here. This current we need. So what is the equivalent resistance of this network? Tell me. So first of all, R equivalent, which is equal to 2, 3. So this is 5. Then how much the supply current is at 2 amperes. So here this current is at 2 amperes. Now we need this current Ix, if I call, and which will divide equally 1 ampere. Next one. In the given figure, the charge stored in 6 microfarad capacitor when points A and B are joined by a connecting wire. These two are joined like this. Right, so then they are supply the battery, that is 12 volts DC supply. Now, so there is a flow of current like this, yes, like this, it will go like this. Okay. So then how much is current value? Tell me now here. So which is equal to 9 by 9, which is equal to what? Tell me now, 1 ampere. So that means this branch current, which is we have a 1 ampere of current will go. So that means how much is voltage? And this voltage is 6 volts. And how much this current? This is also 1 ampere. So this voltage, which is equal to 3 volts. Okay. Now what they ask to find the charge stored in 6 micro. And this voltage same now. So that means we can say now Q is equal to C into V. That is Q is equal to C into V. 6 micro into V value 6, which will be equal to what I can say now, 36 microcoulombs. Next, in the given circuit, the current flowing through the resistance of 20 ohms is zero point 0.3, while the ammeter reads 0.9. The value of R1 is, so this means this current they given as a 0.9 amperes. Okay, the current of 20 ohms. So this current is given as a 0.3 amperes. Okay, so that means how much this voltage here? 6 volts. And this voltage also same now. This voltage also 6 only. And so this current is what, tell me now? 15 by 6. 15 by 6, which will be equal to 3 5s, 3 3s, which is equal to what, tell me now here? 5 by 3. So this value, sorry, voltage 6 now. So 6 by 15. So 3 2s, 3 5s, which will be equal to 0.4. So this current is 0.4 amperes. 0. Okay, 0.3. So this 0.9 means, and this current is what will be now 0.2 amperes. Okay. Now this voltage same now, that is 6 volts only. That means the resistance value is what will be now here 6 by 0.2. That is 60 by 2, which is equal to what will be now 30 ohms. The resistance R1 is 30. Next one. A wire of resistance R and length L is cut into 5 equal parts. If these parts are joined parallel, the resultant resistance is. Then they are asking to find the resultant resistance if these are joined in parallel. Length L is cut into 5 equal parts. So 5 equal parts, each resistance will becomes what will be now R by 5. And these are joined in parallel, so that means will becomes, yes, then this value will becomes R by 25. Parallel now. Next. Yes, in the network shown below, the charge accumulated in capacitor in steady state is. In steady state, so what should be the charge accumulated? Accumulated charge. This capacitor is open circuit, so then equivalent resistance, which will be equal to 10, that is 10 ohms, and this current, which will be equal to what will be now 3 by 10, and which is equal to 0.3 amperes. So this current, which is going high, and the same current I is going here. Now here, so then this current will go 6 into I. So this voltage V, and how much is V value? That is 6 into I. 6 into I, that is 6 into what we have tell me now 0.3. So this V value, which is equal to 1.8. V is 1.8. And they are asking to find the charge, that is Q is equal to what tell me now here C into V. Yes, so C value how much now here? 4 into V value 1.8. So then this value how much now here? 7.2 now? 7.2 microcoulombs. Next, the current through the resistor R2 is, where is R2 here? This current we need. Okay, let's find the equivalent part of this one. So first of all, write these two are in series 6. 6 and 6 parallel 3. 3 will come series 6. 3. So this value will become, 6. Thereafter this value will become 3. And 3 and this 3, which will becomes what, tell me now? So 6. 6 and 3. So will becomes what, tell me? So that is 3 into 6 by, so here 6 and 6. So that is 3 parallel to 6, which will be equal to 6 by 3, which is equal to 2 to series will becomes what, tell me? 4. 4 parallel. 4 parallel will become 2. So finally the current given by this one is how much now? 2 amperes. Okay. This is 2. Now here you can see, now this is, so here this current which will be going here. Now see this thing here. Current will divides. Right. And this current is 1 and this current is 1 ampere will go. And thereafter, so then again this current will divide equally between these two now. So here this current is how much now here? Yeah, so up to here how much this value, tell me now? So this value 6 and 3, 3 and 3 parallel. So here we have this current. How much this current will go here? This resistance is 3. And in this branch, how much is resistance here? Okay, check this thing here. 6 and 3. 3 and 3, 6. Okay, in this branch, if I call this as something I2, this I2 equal to, so that is 3 by 9 into how much now? 1. So which will be equal to 1 by 3. So this current is 1 by 3 amperes. 1 by 3. Then here, so here 6. And so here we have this is 6 will be divided equally, that is 1 by 6. No option. चेक करो कोई गलत किया क्या हमने? This is R2 only na? Okay. So first of all you tell me now here. So these two are in series. How much this value? 6 ohms. Okay, 6 and this 6 are in parallel. Will becomes what, tell me now? So this is 3 ohms. 3 and 3, which will becomes what, tell me? 6 ohms. 3 and 3 will becomes what, tell me now? 6 ohms. 6 and 3. Okay, this thing. So let us redraw this part here to avoid the confusion. So this is 8 volts and this is 4 and this is 2. And here we have the resistance. How much this value? 3 ohms. 6 and this is 3. Okay, next here. So this part here, you tell me now here once again. Now, so this value 6, and thereafter this value will becomes what element of 3. So here this value will becomes what element of 3 now here, and these two how much now here 6. This is 3, and 6 and 3 is what element of here 2. 2 series 4, and then finally equivalent resistance. How much this value tell me now? R equivalent value, which is equal to 2 ohms, and so then this current, which is equal to 4 ampere. So this is 4 amperes. Now here we have a 2 amperes here, and then this is 2 amperes. Yeah, here after coming. So then this current, how much will go here if I call this current is a I2 if I call. Okay, this is 2 ampere we have taken, earlier one we have taken. So this is 3 by 9 into 2. So 3. So this value 2 by 3. So that means, right, so here this current which is equal to 2 by 3 amperes. Now then this is 6, this is 6, then it is 1 by 3. Here we have 1 by 3 amperes. Option D. Yes. Okay. Little confusion while doing the analysis. Okay. Done, everybody? All of you do like the session and share to all your friends. The same manner will continue. The remaining sessions will continue. Okay. I'll encourage to all of you do regularly follow the sessions to have to make your basics are very strong. Right? Okay, then that's it for today's sessions, and we'll meet in the next sessions. Okay, then see you. Bye bye.